Hey guys, today lecture is 13. Today's subject is load includes lot of harmonics because of chorus, and we will learn about K-factor transformers today. Let's move on. First of all, you guys need to know the mainly part of the loss in the transformer. There's two things. The first one is Cooper loss. Cooper is, as you guys know, that there's we use cable, right? Mainly used by the Cooper, right? So when the current is coming to the cable, because of a Cooper itself resistor, so there's a happened resistance. That's why it gotta be loss. Look at that here. Where is it? Okay, as you guys can see, there's Cooper, right? It's a cable. If the current is here, there's something resistance R. And then because of that, we say Cooper loss is current is to 2R. It's gonna become hot, heat, and this is a totally loss. And the second part is as we can already learn about the core loss, right? So core loss include hysteresis loss and eddy current loss, right? If you guys didn't remember this, try to review previous lecture, okay? Let's do more. So what I want to say is, what I want to say is, in the past, our load, is a totally pure RLC. Like for example, incandescent light. But nowadays we use LED or inverters, right? Like for example, semiconductors. So which makes a lot of harmonics. Look at that about the harmonics. Here's number A. A is just sine waveform, right? But what I said is the harmonics. It makes a double or 3 times or more bigger. Look at that, the waveform here. See, right? So for example, if it's the A was 60 hertz, now because of the harmonics, it gotta be 120 hertz. So look at that. As you can see, this is a hysteresis, right? Hysteresis loss is proportional to the frequency, as you can see. But nowadays, as I said, we use the semiconductor or including lots of harmonics load LED like. So that's why look at that here. Eddy current loss is proportional to the frequency is to 2. It's totally different. So nowadays we are considered about the eddy current. Okay, so here just some waveforms. It's a distortion of waveforms. Yeah, that's it about harmonics explained in chorus. And the second part is a K-factor transformer. Maybe you guys never heard about this. So I'll explain a little bit about the concept of a K-factor transformer. So let's see, because of the iron loss, we say this is hysteresis loss and eddy current loss, right? And Cooper loss is a loss caused by the heat due to the resistance in the conducting wire, right? In the cable, when the current flows through the Cooper wire, as I explained it. So because of the iron loss, we use K-factor transformer, right? Heat generated by iron when current flows through the coil wound around the iron. So as I said, hysteresis plus eddy current loss is we say iron loss. This is equation, okay? So what does that mean if we get the higher, harmonics? What happened? Let's see. Look at the guys. This is a transformer, right? And here's a load 1, load 2, and load 3, for example, right? So this transformer, it could make some energies, right? For example, if it could make 100, so the load is gotta be smaller or same, right? But because of the heat, as I said, the core loss, the transformer feel like having one more load here because of the heat loss. Okay, because of the heat, it gotta be energy loss. So it gotta be like, for example, 80. Now the transformer, cannot afford over this part. That's why we use a K factor. Okay, just simply thinking because of the core loss, so we consider the core loss as rating. So we could use the exact the transformer's ability. Look at that here. So look at that. The reason for using the K factor transform is because of iron loss. No, here. K factor transformer or K rating. Here's K rating. Like for example, depending on the load, they recommend us like this kind of load. You need to use this kind of K factor. Okay, just consider. And so what I mean is K factor is used to tackle the overheating of transformer due to the excessive harmonic current produced by nonlinear load. Nonlinear load means, as I said, nowadays load, most of it, like semiconductors, inverters, motors, everything nowadays, and even the LED. So because of that, iron loss happened, right? And why we use the K factor? Because look at here's advantage is that these transformers prevent insulation breakdown by uniformly distributing the stress across the transformers wiring. You got it? So what I mean is that they consider the heat loss. So that's why, the transformer gotta be, not overworking. That's it, the basic concept is. Yeah, today's lecture is done. Thank you guys.